Hello everyone and welcome back to another video provided by SVSU's online tutoring. My name is Joel and today we'll be continuing on with section 9.1 exponential functions, and the topic for this video will be the natural exponential function. So in the past you may have seen this number called e, this guy right here, and it actually has a value of approximately 2.71828. And this is also known as the natural base. Okay, so if you were to see this number and you have the natural logarithm, which is represented as ln, and e and the natural log are inverses of each other. So if you take the natural log of e, you'll get 1, and if you have if you have e as your base and the natural log is up here in the exponent, well, whatever in the natural log gets spit back out because these two cancel each other out. So in this case it's x, so you would end up with an x. And not only that, but the natural base e here is also really important and really common in statistics and physics, pretty much anywhere that you can think of. It's very commonly used in modeling exponential models. So what we have here is that we have the function f of x equal to e to the x, okay? And what we want to do is that we want to graph this, okay? So if I create a table here, and I go -2, -1.5, I can go -1, I'll go to 0, 1, and I'll stop there. So when x is equal to -2, we can update this and say we have f of 2 equal to e to the -2, and that's really equal to 1 over e squared, and that is approximately 0.135, okay? So we'll put a little squiggle there, 135, and you can go ahead and go through and fill out the table here, but we end up with these values here. Oh, actually, when it's e to the 0, it's actually 1. So in that case, we're all good there. And then when it's equal to 1, e to the 1 is just e, so we have 2.718. Okay, and then now what we want to do is that we just want to take these values and graph them. So create my axes here. I have my y-axis and then my x-axis. We want to go about up to 3, so 3 tick marks is okay. And then draw our ticks for our x-axis, and then we just plot everything, and I'll do that in a different color. No, not there, but right about there. And so if we go ahead and draw the line here, again, it's kind of difficult using a pen, but and so as you can see, this graph actually it gets exponentially larger. I mean, it's one of the most common models to use, and so you'd expect it to grow extremely rapidly. You see it with things, in statistics, like with virus infections, bacterial growth, things like that. Interest rate, rate-related problems, things like that. And so, finally, to just end this off, we can talk about the characteristics of this function. So, the domain, let's look at this here, the domain, it's defined for all real numbers, so it goes from negative infinity to infinity. In the range, it has a horizontal asymptote at the x-axis, so its range only goes from 0 to infinity, and then a y-intercept at 0, 1, and again we've talked about the asymptote, and that is the x-axis. So just a quick video introducing the natural exponential function. Nothing too crazy. It's just important that we introduce this because it's extremely fundamental for other types of mathematical problems that you'll see in the future. Alright, see you next time.